A spear is thrown off a high ledge with the given shown in the picture to the right. What is the spear's location after 3 seconds? Neglect the height of the person throwing the spear. In previous problems, to start off the problem, it would say something like a spear is thrown with a vertical velocity of 6 meters per second and a horizontal of 4 meters per second. So what that was doing was giving you parts of a triangle. In this problem, you're given the hypotenuse and an angle. So your first step in solving this problem, before looking at the question, is to draw a triangle with initial velocity of 25 meters per second and the angle of 60 degrees, and calculate or come up with a trig expression for the horizontal and vertical velocities. So here's the first step. Scroll this down a little bit. And down here on the bottom, you can see that I have my triangle. I have my velocity of 25 meters per second and my angle is 60 degrees. The side adjacent to 60 uses the cosine function, so that's going to be the hypotenuse times cosine, which is 25 meters per second cosine. The vertical side, over here, that's going to use the sine function because that is opposite 60. It's not always sine goes with vertical and cosine goes with adjacent. It just depends upon the answer. All you're doing here is using trig correctly. So this is going to be my different components. The spear is thrown with a horizontal velocity of 25 meters per second cosine 60, and the spear is thrown upwards with a velocity of 25 meters per second sine 60. Next, on to the tables. So now I'm going to take my table and I'm going to fill it out. But what I'm going to do this time is I don't want any numbers here for my velocities. Write them as 25 meters per second, don't forget the units, sine 60, and 25 meters per second cosine 60. This is going to help you later on when we've got to work backwards to find the initial velocity. This kind of setup will come in handy. Okay, so we've seen these kinds of problems before. Here's the vertical velocity, the time, and the acceleration is negative 9.8 meters per second squared. Horizontally, the acceleration is equal to 0, and the horizontal velocity is 25 meters per second cosine 60. Next, I've got to find the velocity, the position in the y direction and the position in the x direction. So basically x and y. Here is the calculations for in the y direction, and when I'm doing the calculations in the y direction, I get all my unknowns from the vertical column. Only the vertical column fill in here. So this is basically the x equals x naught plus v naught t plus 1 f a t squared equation, just using the vertical givens this time. Put in my numbers, I get a positive 25 sine 60 because it's going upwards, and my acceleration is going to be negative 9.8 because the acceleration is going downwards. That gives me a y position of 20.9, so it's positive, so it's higher than what it started from. Next, horizontally, those calculations are over here. And when I'm doing those calculations, don't forget to say only in the horizontal column. Don't get anything from the other column. So x equals x naught plus v naught t plus 1 f a t squared. As usual, acceleration is equal to 0, which means it's just x is equal to vx naught times t. We call that the range equation. Range is equal to the horizontal velocity times time. And that gives me a distance of 37.5. Okay, let's put it all together with just a final picture so you can visualize what's going on here. And here's where it is. So in my final picture, I've got my initial velocity and my angle, and the answers were horizontally, it's positive, so that's to the right, 37.5, and vertically, it's a positive answer, unlike some of the previous problems, so that means it's above the starting height. So when I put it all together, I get that for my location of the projectile.